So let's explore the t-test and the null hypothesis a little more. We have three groups, and they all have the same mean and standard deviation. So I'm going to undo my freeze panes here. So when we look at the t-tests for these, this is group 1 versus 2. That's the one we just looked at. And then we have group 1 versus 3. Now remember, we had 966 correct acceptances of the null hypothesis. Here we have 952. So they're all around 950 correct acceptances of the null hypothesis when the null hypothesis is true. What does this look like? So let's look at a graph. And here we have the graph of the two groups. Now this is a probability distribution. It goes from 0 to 1. Really, it doesn't go quite up to 1. But so the peak is at 0 because it's the null hypothesis. These are t-values for the differences between the means. So this is the distribution of all the t-values. And these are the sample t's when the null hypothesis is true. We know the null hypothesis is true because we made it that way. But we took samples. And the thing is, it's not always 0. And that's the whole idea. This is a distribution. You can think of this as the distribution of opportunities or potential outcomes. When the null hypothesis is true, the sample size is 10. And the mean and standard deviations are 116. So this is if you were going to run a sample, you would run your study, and this would represent an infinite number of possibilities, and your study would be one of them. And so when we talk about the null hypothesis, that's what the distribution we're talking about. It's a t-distribution, and the t is going to have a mean of 0. You could also plot the differences between means, but the point is, it's a difference. It's the distribution of the differences, not the distributions of the individual observations for each group. We have our cumulative distribution. Again, if we follow 0 up to about here, we have half the cases are at 0. And if we come up, now this is a two-tailed test, so we look at 97.5 and 0.025 because the 0.25s add up to be 95% or 5%. And so 95% of the observations fall between 0.975 and 0.025. So if we come over here at 0.975, find that crosses about there, we come down here, that's around 2. So our t-value is around 2 of rejecting the null hypothesis. You can see we're almost to 100% when we get here, and we have, when we're at 2 down here, these are all mistakes. These are all mistakes at this end and this end. These are type 1 errors. And we have set our alpha error, our level of acceptance, at 0.05. So alpha equals 0.05. If we exceed it, we have a type 1 error. So when we speak of the p-value, that's the probability of finding a t-statistic as extreme as this or greater. And we are looking at here, the p is 0.05, so that's 0.025 out here, 97.5, 2.5 left, small probability 0.025 here. The combination is what's the probability of finding a t. So we set our t at 2, and this p-value says we want to what's the probability of finding when the null hypothesis is true? Now, this is a case where the null hypothesis is true, and we see that the probability of rejecting the null hypothesis is 0.025, 0.025, for a total of 5%. So we have a 5% probability of rejecting the null hypothesis if the t is greater than 2 or less than -2. That's the meaning of the p-value. The p-value only refers to the null hypothesis, rejecting the null hypothesis, and the p-value represents the probability of finding a t of this value, and it's actually kind of like the absolute value in a two-tailed test of this value or greater.